السلام عليكم ورحمة الله وبركاته.
وعليكم السلام.
كيف الحال يا شباب؟
الحمد لله بخير.
Alright. بسم الله الرحمن الرحيم. It's 8 o'clock, so let's start right away. طيب, last thing I was talking about so far is the Lewis structure and how to draw Lewis structure. I want you to be able now to draw the Lewis structure. Always, whenever we want to draw the Lewis structure, like this question, how should we do it? First, always draw the Lewis structure of chlorine dioxide. Always, almost always, the first letter is the central atom. So you put this one as central atom. And then you put the other atoms like this, or the O and the O. These are terminal atom. All right, that's the first thing. And of course, to make a molecule, there should be at least one bond between them, at least one bond, right? Now, how to draw the Lewis structure? First, go and find the valence electrons. How many electrons do we have for chlorine?
7.
How about for oxygen?
6.
And 5. Total of 9.
12.
Yes. 12. Yes. I'm going down. Now, what's the total number of electrons?
19.
19.
21.
First thing you know about when you see 19, what's that?
Odd.
Odd
What
number.
does that mean?
Exception.
Exception to what?
Octet.
Octet
Octet.
rule. Lewis octet rule. Exactly. Good. Now, but anyway, I want to distribute them. How should I distribute them? Okay. As I said, I prefer always to have pairs. So I'll make 18 plus electron. This means the 18 is how many pairs?
9.
9 pairs plus 1 unpaired electron. Good. This means I have 9. I already used how many of these pairs?
18.
8. Well, how many did I use? Pairs.
2.
2
No.
pairs only. I have 9 pairs, I use 2. And then 3, 4, 5, 6, 7, 8, and 9. And then I have 1 electron, I'll put it here. Now the structure is complete. As everything is okay, satisfied?
Yes.
Yes, very good. All right, let's do more examples. Let's do these very quickly. We'll start with boron triiodide. Again, how to draw Lewis structure for boron triiodide. The first thing, put boron and then put what? At least, first, boron triiodide, where is the central atom?
Boron.
The B. Where is the terminal atoms?
Iodide.
Put the boron and then put the iodine around it like this, and at least you have one bond here, one bond here, one bond here. Now, what's the valence of boron?
3.
3.
3.
Iodine?
7.
7 times
6.
3, a total of
21.
21. And then this is 24 total. This means how many pairs?
12.
12 pairs. Very good. Now I already used how many pairs?
3.
3. And then 4, 5, 6, 7, 8, 9, 10, 11, 12. Is this acceptable structure?
Yes.
Yes.
Around all the iodines. 8
8.
each iodine. How about the boron? How many around it?
6.
6.
Double.
Doctor,
Yes,
shall we mention that the boron is exception?
of course. Is this acceptable to have 6 electrons around boron? Yes.
Yes.
Why? Why? B
Boron takes
exception. Takes how many electrons? Only 6. We also know that Be, what's Be, beryllium, takes only what?
4.
Only 4. Very good. Now, again, let's go to B. Arsenic pentafluoride. Where is the central atom?
Arsenic.
Where is the terminal atoms?
Fluoride.
Fluoride. What should I do before I start even the doing the Lewis structure? I will put arsenic and put the atoms around it. Now, without doing anything, all right, how many electrons around the arsenic?
10.
10. So again, this is what?
Exception.
Exception to octet rule, because what do we call this?
Expand.
Expanded octet. Expanded octet. It's not octet, it's expanded octet. What's the valence of AS?
10.
5.
Is it 5?
Valence 8.
Yes.
5, yeah, I think so. Okay, how about fluorine?
7.
7.
7.
That's 5.
35.
5.
35. Plus 5. 40 electrons. How many pairs?
20.
20 pairs. How many did I use so far?
5.
5.
1, 2, 3, 4, 5. So I have 15 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I'm done. Good. Next. Last example. Xenon pentafluoride. Where is the central atom?
Xenon.
Where is the terminal atoms?
Fluoride.
Fluoride. And I should write the xenon and 4 around it. How many electrons around the xenon so far?
4.
4. Very good. Okay. 4 pairs. 4 pairs, which is 8 electrons. Good. Next. How many electrons around xenon? What's the valence of xenon?
8.
8.
8.
Why it's 8?
Group 8.
Noble.
Noble gas. Very good. How many about fluorine?
7.
Times 4 is
28.
8. Plus 8, 36. How many pairs is this?
18.
18 pairs.
18.
How many pairs did they use so far?
4.
4.
4 pairs. All right. What? I used
14.
4 plus 18. I'm left with 14. So 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then how many electrons are left?
2.
2 pairs. 2.
2 pairs.
Should I put them?
Around the xenon.
Between F and Xenon.
Around the xenon, like this and like this. All right. This means how many electrons now around the xenon?
12.
12.
Oh, very good.
12.
Acceptable. Is this acceptable?
Yes.
Yes,
Yes.
it's acceptable, but it is exception to octet rule. It is called what?
Expanded.
Expanded octet.
Good. Done with this, and that's exactly the shape. You should know how to do these things. Good. Next, we're going to talk about enthalpy, bond enthalpy. Bond enthalpy, very important. All right. And now, what they did, they calculated the bond energy for any bond. For example, H2 goes to H plus H. The energy required for this reaction is 436.4 kilojoule per mole. What does that mean? If you break the hydrogen-hydrogen bond, how much energy you need to break it?
463.4.
Very good. Let me ask you then a simple question. If I want to make a hydrogen-hydrogen bond, what will be the energy?
Negative.
Same as
Minus.
What?
Negative.
The same as minus. Different sign.
It's the same number, but different sign. So generally, if you break a bond, this means you have to put what for delta H?
Plus.
Plus. If you make a bond, you have to put
negative.
Minus.
minus.
Plus.
Very good. Minus for the bond. Good. All right. Now you have to be careful with the Lewis structure. This means the HH here is one bond. Let's look at N2 goes to N plus N. How much energy do we need?
9 for 9.
9 for 1.4. Now, to which bond is this one? What type of bond do you have between N and N? Actually,
Triple.
for the Lewis structure, this is the Lewis structure for N. So this thing represents what type of bond?
Triple.
Triple bond of N gas goes to plus N gas. Okay, if I have N double bond N, what do you expect the delta H will be? Is it going to be 941?
Less than 9.
Will be less than that, definitely. Is it going to be more?
No.
Ever. Good. Now, it has been calculated for so many compounds. So this table here shows you all the bond energies, and you can see that this is single bond, we have OO single bond, we have OO double bond, we have OP, OS, OF, and so on, and CF, CS, and so on and so forth. Now, what's a chemical reaction? A chemical reaction is actually breaking and making of bonds. Let's assume that I have this reaction. How much energy do I need for this reaction? What do you think?
Plus.
What? Give me an answer. Quickly. What's the answer?
Maybe 463.
460 what?
Kilojoule.
No, that's not enough.
Times 2.
Times 2.
Yes, times 2, because we're breaking 2 bonds. Is this clear? Very good. Now let's do another reaction. If I have I want you to tell me What's delta H for this reaction?
For 36.4
For
plus
what?
4
minus 460.
Minus what?
460.
Only 460
400.
times what?
Maybe 3.
2.
No, not 3, not 2. Minus 4 times 460, right? Why did they say 4?
How the
4 pound.
The coefficient of H is 2.
This is not the whole reaction. This is just for the product. Plus what? Two times
436.4.
436.5.4 plus what?
498.7.
142 times 2. Or no. 498.7.
0.7 exactly. See, whatever you break, you put plus for it. Whatever you make, you put minus for it. This is clear.
Doctor, I didn't understand, doctor.
Okay, let's do one more example. Let's say we have N triple bond N plus 3H single bond H goes to 2 NH H. Okay, what bonds you're going to make? What bonds you're going to make?
3 NH.
6 times NH.
3 NH? No, more than
6.
3. You're going to make
6
NH
6
NH bond, right? Right?
Yes.
Right.
Okay.
Right.
And to break how many? Break.
NN.
1
3 NN.
NN triple bond and
3
3
H.
HH.
3HH bond. Clear? Okay. The one you're going to make, you should give it minus, and the one you're going to break, you should put it with plus. So what's delta H for this reaction? It will be equal to what? Minus what? Give me numbers.
6 multiplied by 393.
Multiply by what?
393.
393, exactly. 393. Okay, and then plus. Plus what?
3 times 193.
3 times 193. What's 193?
For the nitrogen.
Oh, no, that's wrong. For the nitrogen, what is the nitrogen? Do we see the nitrogen?
It's not
Oh,
given.
no, he said one. Is this
There is
correct?
no nitrogen triple bond here in the
It's
schedule.
available here. It's available in the other table. Let's go to the other table. Okay, sorry. Where is the NN triple bond? Yes.
941.4.
941.
900.
So yes, I should have 3, oh no, plus 1 times 941.4. Very good. And then plus 3 what?
436.4.
436.4. And that's it. You add them together and you have the answer. Is this clear, everybody?
Yes.
Yes, it's
Very good. Let's do this example then. Okay. Now, we are going to do this reaction. Now, I want you to take notes and then we will go to the table to get the points. What is the delta H for this reaction? It will be what? Minus 4 times what?
CH.
Times bond energy of CH. Very good. And then minus again, what? Two times what?
Two,
Bond energy.
bonding energy of O2.
O, not O, but how many?
Double.
Double bond O. Good. And then what?
Plus.
Plus. Yes. What is it?
4 CO.
Doctor, isn't it supposed to be opposite?
Yeah, why did we make the reactant
Oh.
minus?
Yeah, the reactant should be plus because we break bonds.
Plus. Thank you. Yeah, I can make mistake. Of course I can. Okay. Yes. This is plus and this is plus because we're breaking. And this is the minus now. Yes. Minus what?
One
CO2.
CO, double bond.
One or what?
Two.
Two
Two
times.
CO, double bonding.
Exactly. And then minus again.
HO.
4 bond energy of what?
HO single bond.
OH single bond OHO. Exactly. Is this easy?
Doctor.
Yes.
And the third one, why OO?
The third one, O double bond. Oh, what am I saying?
CO.
Mistakes, sorry. I'm making mistakes. I'm wrong again. But it's 2 times C double bond O.
Doctor,
Yes.
when will they announce the date of final exam?
This is after the lecture, we'll discuss it. I don't have any information. Do you know how to do this now?
Yes.
And these are the numbers for each one, as you can see here, plus 4, 4 and 2, and 2 times CO double bond, and 4 times OH bond, and you have the final answer. I hope this is clear. And this is actually the end of chapter 8. So was this one. And right away, we'll go to chapter 9. And chapter 9 title, can you read chapter 9 title? What is it? What's the title of chapter 9?
Chemical bonding to molecular and geometry in bonding
Chemical
to
bonding 2. What was the title of chapter 8?
Chemical bonding.
bonding one.
So what is chapter 8 and 9 are what?
Are the three topics.
Very good. Now, in chapter 9, we're going first to talk about valence shell electron pair repulsion model. I want you to look at these names, and then I'll tell you the full name, and I want you to memorize VSEPR model. Okay. Now, this VSEPR SEPR model is written here. What's this model called? Valence shell electron pair repulsion model. And it's VSEPR, the first letter. VEPR. The VSEPR. Is this clear? I want you to memorize the name. Valence shell electron pair repulsion model. Valence shell electron pair repulsion model. And this model predicts the shape of the molecule. The shape of the molecule. Okay? And we're going to talk about two important things. First, we have to know what's valence shell, valence electrons. We know what's valence electrons, right? What's valence electrons?
Outer shell.
Last what?
The last SP.
Last sp electrons. Last sp electron. We have to know what's central atom. What's central atom? Yes? Hello? Central atom is the one which is what?
The middle.
In the middle, that's it. What is terminal atom?
On the sides.
The sides. Very good. And then I want to make new definition, which is the electron domain. Electron domain. Electron domain. Electron domain. And I want to write, the last thing is molecular shape. Molecular shape. All right. What's the electron domain? The electron domain, that's very important. You have to memorize the name very, very well. Electron domain. What's the electron domain? Any bonds is, whether it is single or double or triple, we'll consider to be electron domain one domain, B. I'll call it, from now on, I'll call the bonds as B. But whether this B, it will be B1, whether it is single bond or double bond or triple bond. Okay? And when I have electron pair like this, then I'll call it E. Each electron pair will be called E. And I will call the central atom from now on as A. So let's write the electron domain for CO2. CO2, I will call the C here what? A. Why do they call the C A? Central atom. And then each bond around the central atom, I'll call it B. So how many electrons do we have here? 1B. Why did I say 1B?
Double bond.
Double bond or triple bond or single bond will be also B. And this one is also B. And so I will write 1AB, 2. And then how many electrons around the carbon? How many electrons in the domain? Nothing. That's why I will write the domain as E what? 0. Good. Let's do it for oxygen, this oxygen now.
Doctor,
Just a second. I will call the central atom as A. And each one of these, I'm going to call it what? Yes,
B.
B. How many B do we have?
4.
No. How many
3.
B? Only 2. Why 2?
just 2 bonds, no matter how long is it or how strong is
A
it.
double bond here, a double bond here, which is this one, and a single bond, which is this one. Each one is going to be called B. So this is AB2. And then is there unpaired electron or share unpaired electron here around the oxygen? So this will be E what?
Zero.
No,
4.
E1.
E1. This is unpaired electron. Unpaired, not unpaired, unshared electrons. There is one unshared electron. Okay. Unshared electrons. Okay, good. Now, let's do it for this one. I'll call the nitrogen as A. Then, B what?
B3.
3.
B3, fantastic. Why?
3 bonds.
3 bonds.
3 bonds, exactly. And then E what?
1.
Very good. Now, do you have any question about the electron domain?
Yes, Mr.
Yes.
We don't count the lone pairs in the terminal atoms.
No, we can't. I'm concentrating now on the central atom only. So I want the electron domain for the central atom. I can do it for, if I want, let's say I want the electron domain of this atom. What's the electron domain of this oxygen? What is it going to be? It will be A. What? Yes, help me.
E4.
B1.
What? EB what?
AB1,
0.
No.
A2,
B what?
2.
No.
B1.
B1.
1.
E1. It's double bond.
Yes, E2.
And E2, exactly. That's the electron domain, exactly. Is this clear? Very
Yes.
good. Let's do it one more time. How about this one? What's the electron domain of this one? Of P?
AB.
AB5.
B5,
B5.
B5.
E0.
0.
0, exactly. Very good. How about the xenon?
AB4.
AB,
AB4.
B4, E2.
E2, fantastic. Very good. All right. How about this chlorine?
AB1.
AB1,
E3.
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 E3, fantastic. Yes, super. Is this clear?
Yes.
Yes.
What do you call this AB1, E3, or whatever?
The Vesper model.
No,
Electron domain.
electron domain. We call it electron domain. We will use the Vesper. Well, I don't know from where you got the word Vesper, but we call it valence shell electron pair repulsion model for me. All right. Good.
Doctor.
Now, yes.
So the electron domain is the number under the B plus the number under A.
No, just a second. Yes, I'm going to talk about it. No, the electron domain is to write this thing. Okay, and then if I tell you how many electrons or what's the electron domain, total electron domain, you should give me the total number of B plus E. So look here, what's the total B plus E?
5.
5, and that's why we have 5 electron domain around the A. How about what's the electron domain of A? What's the total number of electron domain around A in xenon F4?
6.
4.
6. Is this clear? So what is this 5 and 6?
Electron domain.
Electron. Total electron domain.
All right, yes, total electron domain. Now after that, I'm going to talk about the shape of the electron domain. The shape of the electron domain, all right? The shape of the electron domain depends on this number. We're going to talk about mainly 2, 3, 4, 5, and 6 only. Okay, the total will be that we're going to talk about the total electron domain is going to be 2, 3, 4, 5, and 6. If it is 2, then it will be the shape of the electron domain will be linear. What's linear means?
خطي.
Straight. Okay.
The straight line.
What?
Straight line.
Straight line. Straight, yes. So if we put the atom here, it will be something like this. And as a result, what will be the angle here?
180.
180.
Yes. You have to memorize this angle as well. 180. Good. If it's 3, the shape of the electron domain will be what?
Triangle.
Triangle. Like this. Okay? Triangle. Triangle. What will be the angle in here?
60.
No. Come on. What's the angle? What's this angle?
120.
120, yes. This angle 120, 120, and 120. Clear? You have to memorize the name and the angle. What's the name of 3 electron domain?
Triangle.
Triangle. And actually, the shape of the triangle. So this is, what's the electron domain for this shape?
Linear.
2 electron domain. What's the electron domain for this one?
3.
3.
3 electron domain. 3 electron domain. Which we do. What's the angle in here?
120.
120.
Exactly.
120.
What's the angle in here?
180.
180.
You have to memorize this. Very good. Let's go back. If we have 4, we have another shape. I'll show you the shape, but this is called tetrahedron. You have to memorize the name very well. What's the name?
Tetrahedron.
Say it one more time. Tetrahedron.
Tetrahedra.
Yes, tetrahedral. And the angle here is 109.5. All right, 109.5.
to memorize it.
Yes. As I said, here, even the angle, you should know it from math, but here, at least for me, just memorize the angle and the name. It's tetrahedral and 109.5. 109.5. And this is actually the shape of the molecule. It's like this. So what's the angle in here? This is electron domain 4. What's the angle?
109.5.
109.5. What's the name of this shape?
Tetrahedral.
You have to memorize the name very well. All right, and the angle. Is this clear?
Yes.
Next, if we have 5, then we're going to have the name is trigonal bipyramid. Memorize the name, trigonal bipyramid. Sometimes we refer to it as TBP. TPB. What's the name? Read it.
Trigonal bipyramid.
Pyramid, trigonal bipyramid. And this is the shape of trigonal bipyramid. You can see here, there is a triangle at the bottom and one up and one down. Good? In the triangle, which is at the bottom, like this, I'm talking about these 3 now, 1, 2, and the back there, 3. It's like this. What's the angle in between them?
120.
120. Why? Because it's triangle, right? And this one is perpendicular to the triangle. Can you see this one is perpendicular to this triangle? So what's the angle, this angle here?
90.
90. So we have 2 important angles. What's this angle between this one and this one?
120.
120. This angle is 120 and this angle is 90. Is this clear? What's the name of this shape? First, what's the electron domain for this shape?
5.
5. What's the name of this shape?
Trigonal bipyramid.
Trigonal what?
Bipyramid.
Bipyramid, which is TBP if you want. Is this clear? Good. I hope it's clear. Good. Let's go to the last one, which is 6. 6 is called octahedral. Octahedral. Okay? You have to memorize the name. Octahedral. What's the shape of octahedral? This is the shape of the octahedral. It's a square down there, and one up and one down. What's first, to which group, or what's the electron domain for this shape?
6.
6. What's the name of this shape?
Octahedral.
Octahedral. You have to memorize the name. What's the angle in the square of this square? What's the angle between this one and this one?
90.
90. Good. What's the angle between the one at the top and this one? There is one up and one down in the square.
90.
90.
90. So the only angle that we have here is what? 90 degrees.
90.
What is the only angle we have for tetrahedral?
90 degree.
Tetrahedral.
109.5.
105. Trigonal bipyramid.
90 and 120.
90 and 120. You have to be careful which one is which. Clear? And for octahedral, we have 90. Okay? And remember that for straight, which is 2, what's the only angle we have?
180.
180. This is straight. Or called linear. No problem. And this one is called what? This is 3. What do you call it?
Triangle.
Triangle. And what's the angle we have? Only angle.
120.
120.
I want you to very well memorize what I wrote here. Memorize everything. The electron domain, how to find it, the name of the shape of the electron domain, and the angles. All of this important, and you have to sit down and memorize it. It will take you 5 to 6 minutes to memorize them. Is this easy? Is this easy?
Yes.
Very good. Now, we're not done. Good. This is the shape of what? So far, I'm talking about the shape of what? So far, we're talking about the shape of?
Orbit.
Electron domain.
Yes, electron domain. What do we mean by the electron domain? Total what?
Electron.
Total B and
E.
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 What's B and E?
Bonds and double.
Bonds and electron,
Bonds.
unshared electrons. Unshared electrons like this, and bonds. Clear? And the bond, whether it is double bond or single bond, is the same. Good. Now, as I said, we are talking about electron domain shape. Electron domain shape. Let's look, but now I'm going also to talk about, there is electron domain geometry, and I'm going to talk about molecular geometry. Why is that? If we have electron domain, what's the electron domain for this molecule that you're looking at here, for this central atom? A, B,
E2.
AB2,
E1.
1. What's the total?
3.
3.
3. Total 3. So what is the shape for electron domain?
Triangle.
Triangle.
Triangle. Triangle planar. Exactly. What's the angle in here?
120.
120. 120. All right. This is the electron domain theory. Good. Now we want to know the real shape. The geometry, the shape, we cannot see the electrons. So we will see the same shape, but since we cannot see the electrons, our machine, now we can see this by machine, by the way. We can see the atoms by X-ray diffraction, but the electrons, we can never see them. So we are not going to be able to see the shape. So the shape of the molecule will be similar to this one, but we're going to see it like this. And that's why we're going to call it bent, not triangle. So the geometry will be bent, even though the electron domain geometry is trigonal planar. But the geometry for the geometry, just the molecular geometry, will be bent. Not only that, but also the electrons that we don't see, they take more space than the bonds. As a result, what will happen to the bond? The unshared electrons take more space than bonds. So as a result, this angle will be what? Greater than 120. Okay? How about this angle? Hello?
Yes.
It will be less than
120.
120.
Less than 120.
Less than 120. Is this Clear? Is this clear? Okay, so again, the only difference between the electron domain geometry and molecular geometry that we cannot see the electrons. So the electron domain geometry, we assume that the electrons are there and we give the shape according to the electrons and everything. That's why this becomes triangle. But when we go to molecular geometry, we'll say we cannot see the electrons. Not only we cannot see the electrons take more space than the bond, and that's why this angle will be more than 120, and this angle will be what? How about this angle?
Less than 120.
No, between the electron, between the
It will
electrons.
be more than 120.
Also one more than 120. And this one will be less than 120. Is this clear? And the shape name now is called bent. So if I ask you, what's the shape of this molecule? From electron domain point of view, what's the shape of electron domain shape? What are you going to say?
Diagonal or planar.
If I say, what's the geometry of this molecule? What are you going to say?
Bent.
Bent. Sometimes they call it V shape, which is the same thing. It's like V shape. Clear? Bent or V shape. You have to memorize the name also. And I'll stop here, actually, and let's go check the attendance very quickly. So the attendance now is open. Go ahead, take the attendance, and you can leave right away.